My, I think, first or second slide is to present Siemens, and it looks a bit ridiculous after the previous presenters didn't present the company itself and its origin, and I come from this tiny company and I have a slide about who is Siemens. But anyway, what we're doing at Siemens here in the Israeli site in Airport City, and actually we're doing that for about a bit more than 30 years now. It's an Israeli company, Technomatics, that was purchased by UGS, an American company that later on was acquired by Siemens. So now I'm Siemens, and we're doing robotics and robotic simulation for the manufacturing facilities. I would say something like 80% of our activities are around automotive, the automotive industry, aerospace and defense and others, but here I will focus on automotive. Just a minute, what happened to this window thing? Okay, so this is Siemens doing a lot of things. I will not cover everything here, and I'm part of the digital factory division. It's a huge company, a lot of numbers here. How much time do I have, by the way?
Well, 20 minutes from the moment you started.
Okay, so I assume that most of you recognize all or most of the logos here, and you see here on the left an automotive facility, and thank you Hagai for mentioning automotive manufacturing lines. It will maybe help me here to explain. And an airplane facility, and these are most of the things that we do. We support the companies that build cars, that builds airplanes. It's a huge challenge to manufacture these kinds of very complex products. A lot of challenges when you take into account all the standard things as quality, time to market, cost, layout of the facility, energy consumption, and so on, flexibility, and so on. And today you cannot really be efficient without using tools to help you to plan the manufacturing operations. And this is what we do. And I will use the 20 minutes, 18 minutes maybe, that I still have to make you wonder, make you think, imagine how I see here many young people, maybe with crazy, very good ideas. Maybe they have really great minds and great ideas, great technologies, but maybe some of you don't know what to do with this technology. Maybe this will help you to map things and ideas that you have in mind to help these industries. And I'm here to talk to you, to provide some, maybe to advise. Omri and Shaul are here too. Raise your hands together here from my team. You can talk to all of us, and maybe you can together think about something, how to improve processes to help you, to help us, whatever you prefer. So I will use automotive as an example. I don't have time to talk about other industries, but I think it's good enough for now. A car, a body of a car, made out of sheet metal panels after the press line. And in a car there are something like, can you imagine how many sheet metal panels there is in a typical family car? Any idea? 200. 10,000? Okay, so something around between 800 to 1,000 panels. And they are built in sub-assemblies along the line. A line consists of a couple of tens of stations. In each station, several robots. The idea, the robot takes a panel, move it to a fixture, to the assembly, and then other robots, or the same robots, welds. Usually we use spot welding. The automotive industry is still using spot welding technology. There are other technologies being implemented, but this is the standard. And then eventually you get the car, another piece, another sheet metal part, and another one, and eventually you have the body, and then it goes to the paint, and goes to the final assembly line, and you get a car. How many spot welds in a car, more or less? Any rough estimation?
30,000. 30,000.
30, okay, so between 3,000 and 5,000 depends on the technology, on the car, and so on. It's a lot. So there are something like 800 to 1,000 robots in a complete line. A lot of panels, a lot of welds, and then the main challenge is how to do this, how to do it efficiently, how to save cost, how to reduce the assets cost of the robots, and a lot of questions like that. I will show you several very short movies of lines, and then we can talk about the challenges, how we solve them, these challenges with the Technomatics tool. This is the brand, the Israeli name, so it's still the brand of Siemens products. And then maybe you have ideas, so talk to us. So this is how a car looks like at the beginning. Okay, and this is how it looks like. It starts like that, just a roll of sheet metal. And it goes like this, and then this is the press line. What is this? If I will stop it. What is this panel here? In the car, what will it be? A door, a side, yes, a side, exactly. So these will be the not the windows, the holes for the doors, actually. So this is the press line, the arms taking the sheet metal, press machine, after a press machine, and the shape of the side of the car is being assembled, manufactured here, performed here. So you see, this is the end result of this panel, and then it goes on and on and on. This is the routine. I will show you another movie. Okay, this is very fast here. These are the robots. ABB robots, looks to me. And some of them are taking parts from a fixture or from a rack to a station, and then other robots welds the panels together. And when you say a line, well, here it doesn't really look like a straight line. It can be very complex in terms of the layout, and this is one of the challenges. So this robot takes the underbody in this case to another station, and the other robots will doing, this looks like an arc welding process, not a spot welding. And this looks like a torch here. This one here. With the aluminum bodies, arc welding is quite popular. We continue here. Okay, goes on and on. Another example. I show you this just in order for you to understand and to get a feeling about the complexity of the process. A lot of robots working very close one to another, a lot of reachability issues, a lot of collision issues, a lot of challenges around how the weld gun, this big thing was a weld gun, all these end effectors. This is the tip of the weld gun that needs to weld these spot welds. So how to reach all these spot welds around the vehicle. This is a huge challenge.
Are they
Seeing the robots? I would say in many cases they are blind. There are a lot of sensors, different kinds of sensors, but basically what they know to do is how they were programmed. So there is a program that tells the robot what to do, and this is what they do every cycle. So every car might be different model, different variant, with sunroof, without sunroof, and so on. So there is a barcode for each body, and then the robot may have various programs, and the robot knows that for that body needs to do this program, and for another one, the next one in the line, the robot needs to do something else. But it's not really, the robot is not that smart, and this is one of the challenges, by the way. Okay, I will stop here, let's continue. Another line. You'll see all the robots are waiting and together working. Again, I hope that you can really feel the challenges and the difficulties, how to do that in a very efficient way. Paint is a bit different. The robots are different. The robots are opening and closing the door, the hood, and then they spray and they paint. The challenges here are quite different. It's about the quality of the painting, thickness analysis. It should be very constant with the thickness, coverage analysis, how to not waste material, and so on. I'm really trying to be efficient also in my presentation here. So when we're talking about the challenges in the automotive industry, and I focus only on the body in white area where all the robots are working, not in the final assembly section where it's more manual, labor-intensive work. So here we can see that I mentioned the panels, the assembly order and the sequence. What should be the best assembling sequence? Which panel should be the first one, the second one, and the third one? Which panels do I assemble in the 5th station compared to the 10th station? A lot of challenges like that. And of course also spot welds order. Okay, so I have, let's say I have 2 panels with 10 spot welds that assemble them together. Should I weld all these 10 together at the same station or distribute it along the line? Layout. So how should I build my layout in case of a greenfield scenario where I build my new facility, for example, in order to be able to support the assembling of my car? And it's not one car, we need to support flexibility. Guy mentioned that. So today I'm planning and I'm manufacturing this model, and tomorrow I need to manufacture a different one. Not mentioning that today it's very common to see on the same line different models being assembled. And this is again another challenge, how to keep flexibility to a high level. Energy consumption, so it's really the energy in a facility with 1,000 robots, it's enormous. It's really crazy, and each reduction of each reduction in energy consumption is really valuable and appreciated. Cycle time, of course, we need to reduce the cycle time every time. Flexibility, we mentioned that, and all that under the assumption that striving for highest safety along the line, quality, cost, and other parameters that probably you know well. These are some movies from our, let's say, leading solution. We have several solutions. This is Process Simulate. So you see here the final, the simulation of a process. It's one-on-one based on CAD data that company designs and build. You have the robot, you design everything step by step. Today, I must admit, most of the things our customers which are using our software, the solution, the tools that we provide are, I would say, semi-automatic in a good scenario, or manual in many other cases. So you need to go to each and every robot and define its location and try to find out which welds it needs to weld, and station after station after station. There are additional solutions or tools in the software that improves that. So we have like an automatic path planner to plan the motion of the robot without collisions. So the robot can bypass obstacles on the way. Other tools, it's not a training here, but other tools to help you identify the optimal robot location and other parameters that are required here. In this case, the robot needs to assemble the roof of the car. So you have here the rack with all the roofs. Okay, and this is the robot with a gripper. And now the user in Process Simulate tries to identify where it needs to put it, and then tries to look for collision. So here, this is the picking location. But if you will check for collision, we'll identify that there is a collision here between this arm and the side of the rack here, the pillar. So then you can move the robot a bit until there's no collision. And this is how it goes on and on and on. I think that I don't have much time. How much time? 5. Okay. I did run a bit. Any questions so far?
Yes. Yeah. There was a question about blindness and the ability to see. So if the shield of the car would be slightly offset, would the robot localize or have the range?
So you're talking about calibration? So when you say slightly different, let's say...
I'm talking about whether they are aligned only because the shield is oriented and positioned in a certain position, or there's the ability to adapt to a slightly different position?
In most cases, no.
There's no ability?
No, the assumption is that it's very accurately positioned and fixtured, and based on that, robot knows what to do. Sometimes, in some cases where accuracy is very important, then there is other techniques. Some of them are coming from the mechanical side, not rather than software, let's say. So the tips of the weld gun will smoothly get to its very accurate position. Okay, for example. Okay, so you can, it's not a training. These are representation of some weld spots here. And then if you will add, move a bit forward here. Okay. I'm adding the robot here, and I can do a test of reachability. So all blue means all these spot welds can be reached by the robot, but if I take it further away, then you start to see orange and red locations, which means that the robot cannot reach them. So, but you see that it's quite manual, the process.
So you don't do it, essentially you don't do any optimization?
Not in this sense. And this is maybe something for you to help us or to invent something new here to help the industry, okay?
So why do you call these robots at all? Why do you call these machines robots? It's just like to call elevator a robot because it moves by itself.
What is the definition of a robot?
I don't know.
Exactly. The thing.
I think if you will look at any report about industrial robots, you will see that these are robots. These are the most dominant robots in the market. The number of robots, these elevators or machines or whatever you want to call it, these are the dominant ones. You have the most of them in the industry. I do think that they are robots. They have controllers. You can add to them and mount to them any kind of sensor, but they don't have their own brain. They don't take decisions by themselves, not yet. And again, maybe this will change soon. Okay, I'm continuing here. I'll skip that. Hagai mentioned the Industry 4.0, the fourth revolution. So if you'll ask different people from the industry what is Industry 4.0, probably you'll get various answers, but I think that the technologies that you see here are more or less what everybody is talking about. And we believe that there's a lot for these technologies to help improve the processes in automotive. Again, automotive is just one example. I mentioned also aerospace and defense and maybe others. These are several projects that we are doing now around AGVs, around cloud, around VR technologies and AR technologies. Some of them are already products, commercialized products that we have released. Some of them are just explorations, experiments that we are doing, prototypes that we're doing together with customers. And again, my purpose to come here and to speak is really to make you think and brainstorm if you want after that, and if you have good ideas how to support these industries with big data analytics, algorithms, with AI and machine learning, all these great things that probably some of you are in and are expert in. This for sure can help to improve the industry. MindSphere, Siemens MindSphere is a platform to collect data. It's like Internet of Things, or platform to collect data from the shop floor, and then it invites everybody. So I invite everybody here to build applications on top of the data that MindSphere collect from customers. So there is again, I don't have time, but eventually there's a lot to do here. And again, as I mentioned, my purpose is to get ideas from you for Siemens, or to help you. Feel free to come with the idea that you have your own startup. You don't need Siemens here, but you just want to get our advice, to leverage our experience. So feel free to come and ask. So, sorry?
Where is the data? You say you have a lot of data.
The data? Come to talk to me about MindSphere. Questions?
Two questions, please.
Yeah.
Where are these production lines in Israel being implemented? The first one.
Let's start with this.
Okay.
So, are you asking in which companies are using our software?
Yeah.
No one.
In Israel, no one.
I don't recall a mass good big automotive industry in Israel.
Not automotive, but...
So IAI is a small, very tiny customer of us.
Okay, and in the world, do you see construction facilities using robotics? Pretty question.
Like
אתרי בנייה.
constructions, robotics in constructions. I do see another topic, maybe not related to here directly, is 3D printing. And we do see prototypes of 3D printing in constructions. Some, I don't have here movies, but sometimes you see more and more these big robots, believe it or not, on rails or overhead rails, huge rails of tens of meters, running back and forth inside, for example, the Super Jumbo, Airbus Super Jumbo A380, to do drilling and riveting processes inside and outside of the fuselage of the plane. So still, it's a plane, it's not a huge construction facility, but maybe this can help. I don't know. Another question you had? No. Yeah.
If you could change one thing to make cars cheaper, what would you change? In the process, of course.
Process? Again, I try to emphasize that the process is still, even without our great tools, still very manual. And I'm sure that the result is far from being optimal. So if you maybe can bring up an idea with big data analytics and other technologies that are recent years evolving, to be able to help BMW and Audi and all these companies to optimize their processes, the layout, the number of robots that are needed, and so on and so forth, then building a car can be much cheaper. I don't know the percentage of really the direct cost of building a car and the price that you pay to purchase it. It's a lot of margin going to many players here on the way. So, but from manufacturing cost